So this is problem 18 of the MIT Integration B Qualifying Exams 2012, which is the indefinite integral of 1 over the square root of 2x squared minus 1. Now this is interesting, and I hope you learn a few things too. We're going to do a little bit of acrobatics to get this solved. So my wish is that you hang around with us as we try and solve it. How do we solve this problem? This is my proposal. I would pull out a -1 such that we have 1 minus 2x in the denominator, right? And I'd like to substitute something in place of x such that I could factorize everything and the denominator cancels out. So with something that would be in the denominator, and that would be maybe saying let x be equal to root 2 in the denominator, 1 over root 2 cosine theta. And so when you say cos dx d theta, that becomes negative 1 over root 2 sine theta. And so dx can be substituted off with 1 over root 2 sine theta d theta. So this becomes our something we can use to do the substitution for x, right? So and this here is our iconic imaginary constant. So then what we have is 1 over I integral of -1 over root 2 sine theta in the numerator, 1 minus cosine square theta, which is integral of root 2 sine theta over sine theta, which is equals to 1 over, as a negative, root 2 integral of 1, and so we have negative 1 over I root 2 theta plus the integration constant. So let's stop there for a minute. We do have to express everything back into the x domain. Now, we have I don't like this I don't like it at all there. So let's go back. We said cosine theta over 2 was x, meaning that cosine theta would be bad. And from Euler's expression over 2, which means that is equals to 2 root 2 x. And multiplying across, we have 2 plus 1 is equals to 2 root 2 x theta. Okay, meaning that plus 1 equals to 0. If we just keep this temporarily as u. So this becomes u squared minus 2 root 2 x u plus 1 equals to 0. And using the quadratic formula, u becomes 2 root 2 x plus minus b squared is 8x squared minus 4 divided by 2, which pulling 2 out, remaining with 2 root 2x plus minus 8, 2 rather, 2x squared minus 1. Okay, so that's interesting. Let's keep going. So we said u is equals to root 2x plus minus 2x squared minus 1. And since u is the same as e to the power theta, that becomes 2x minus 1. And therefore, I theta is equals to, taking natural logarithm on both sides, minus 1, such that theta is equals to 1 over I, natural logarithm of root 2 x plus minus 2x squared minus 1. Initially, we had found our integral to be equal to negative 1 I root 2 theta plus c. So we substitute in place of theta, we have um, 1 over I natural logarithm of 2x plus minus 2x squared minus 1 plus c. I and that becomes negative 1, and so that negative 1 cancels with that. So we're left with 1 over root 2 natural logarithm of root 2x plus minus 2x squared minus 1 plus the integration constant. So that there is the answer for the integral of 1 over 2 squared minus 1. So we probably started with a more complex approach to it. Let's see if there is a simpler approach to this. So there's going to be method 2 for this. Let's see how we can do it. Let's see method 2, and probably this might be simple. So we have an integral of 1 over the square root of 2x minus 1. You can say let u be equal to, right, such that u squared equals to 2x squared minus 1, and so 2u du dx is equals to 4x. And so what happens is that 2u du can be used to substitute off for 4x dx. The bigger challenge here is that what is x, right? So from here, u squared plus 1 will be equal to 2x squared, and so u squared plus 1 over 2 will be equal to x, and so the 1 over root 2 square root of u squared plus 1 would be equal to x, right? And so we can now try to approach the 2u du being equal to 4x dx. You can say this is 2u over 4x du equals to dx. That means over 4 square root of 2 square root of u squared plus 1. Therefore, root 2 over 2 is 1 du can be used to substitute for dx. And so what now we have is the integral 2x minus 1, this being u, is the same as 1 over u, and here we have root 2 over 2 of u square root of u squared plus 1, right? And that cancels out. So we have rather so this actually becomes, this is easy, the integral of 1 over square root of u squared plus 1. Let's proceed and see how we can handle that. If those of us who know hyperbolic cosine x minus sinh squared x being equal to 1, that means cos squared x is equals to 1 plus sinh squared x. So using this identity here, we may be able to substitute something in there, right? So I will say let u be equal to let's use a hyperbolic sign, and let's use a variable, for example y, such that du dy is equals to cos y, and so du is equals to cos y dy. So we can substitute of du with this, so that our integral root 2 over 2, which I think this is the same as 1 over root 2. So I'll just go ahead and delete that and just say okay. 2, and we have it's the same as 1 over root 2 cos y dy over the square root of 1 plus sinh squared y, which is equals to just 1 over root 2, because this and that would cancel based on the identity we have of, so we have the integral of 1 in the, so since our integral is now the integral of 1 in the y domain, and we get that, but we had say that let e equal to sinh of y. So in other words, e to the power y over 2 would be equal to u, meaning that e minus y, e negative y equals to 2u. And therefore, what that means is that e to the power 2y minus 2u to the power y minus 1 equals to 0. So ey would be equal to 2u plus or minus square root of 4u squared plus 4 divided by 2. And we can pull out and we have u plus minus u squared plus 1. Now, clearly this guy is greater than u, and we, I think, would ignore the minus and just keep that for now. However, the question is, what is u? What is u? So we found that e to the power y would be equal to u plus the square root of u squared plus 1. And therefore, y would be of u plus square root of u squared plus 1. And since our integral had led us to, instead our integral now would be u plus u squared plus 1 plus the integration constant. Now what is u? Since u had been equated to 2x, a square root of 2x minus 1, our integral now that is of the form this guy here now becomes plus c u squared is equal to 2x squared minus 1, and that means that u squared plus 1 is 2x squared, and therefore square root of u squared plus 1 is equals to root 2x, right? Meaning that now our integral in the x domain would be equal to 1 over root 2 natural logarithm. In place of u, we have 2x squared minus 1, and in place of u squared, square root of u squared plus 1, we have root of 2x, plus the integration constant, obviously, but that really is our answer. So two different methods, but you see that you probably will be led to the same answer.